Hello and welcome to the Math Bender. I'm Adnan Zaidi and this is an extension of trigonometry where we'll discuss further on the applications of trigonometry, more or less, which is angle of elevation and depression. So let's start off. Let's assume that there is this person standing here, and if you look at it, this is the line of sight, which means line of sight means that you don't have to look up or look down. The thing that you're seeing is exactly of your same height. So let's say if there is a fan here somewhere at the top, if you were to look at that, you will have to look up. The lift in your side is called the angle of elevation. How much are you elevating from your line of sight? And if you're looking down, then this is your angle of depression. So in simple words, looking up is the angle of elevation and looking down is the angle of depression. For example, there's this person on a tree and there's this another person who's trying to see the other person from the ground. So both of them, if they are having an eye contact, so which means the person standing at the bottom is elevating his line of sight to view the person who is on the tree. But the other person is actually depressing. So that is the angle of depression. So let's assume there is this second person and there is this first person. The amount of elevation is this. The first person's line of sight is this. So this is the angle of elevation. This is the angle of elevation. And if the second person's line of sight is this is line of sight, then this is the angle of depression. Now can you see that it actually makes a Z or an alternate angle, and we know that alternate angles are equal to each other. So if they're having an eye contact, so the amount of angle of depression of second person is as same as angle of elevation of the first person. So let's see in some of the practical examples in our questions. A boat is approaching a cliff with a lighthouse on top. As you can see that the cliff is 100 meters high and the lighthouse is 30 meters tall. The angle of elevation, this is our line to focus on. The angle of elevation from the boat to the top of the lighthouse is 20 degrees. Calculate the distance of the boat. So let's make a rough diagram. So let's assume this is the height of the tower. This is where the boat is, and the distance between the boat and the foot of the cliff, we need to find that out. And this is the angle of elevation. He has to elevate 20 degrees in order to view the top of the tower, which is 130 meters. So it is a case of right angle triangle. So we know that this is going to be the opposite and we need to find out the adjacent. So we apply tan of 20 equals to opposite over adjacent, and in this scenario opposite is going to be 130. So adjacent is going to be 130 over tan 20, which gives you 357.2. So the ship is at a at a distance of 357.2 from the base of the cliff. The ship is not moving, but the captain of the ship is now eyeing the height of the cliff at the high base of the. So, if we try to look at this and try to make another triangle, which is now the top of the cliff, not the top of the tower. So, the angle of elevation is obviously going to change. But the distance here is 357.7 because the ship is not approaching towards the cliff. So this is going to be 100, and now I need to find how much the captain of the ship has to elevate in order to view the height or the top of the cliff. So according to this angle theta, we know that this is going to be the opposite and this is going to be the adjacent. So we know that tan of angle theta, you may use x if you feel like, opposite over adjacent, which is 357.7. So we use theta is going to be tan of inverse, separating the angle with the trig function. So you use shift tan 100 over 357.7 is going to be 15.6 degrees. So now the angle is going to be 15.6 degrees, which means he has to elevate from his line of sight 15.6 degrees in order to view the height. Let's take another example. So light is L is fixed on a building 8 meters above the base. So this is the height from the ground of the bulb, and a point P is a horizontal ground from B. We calculate the angle of elevation. So this is the distance, horizontal distance. All you have to find out is this angle, which is, according to this angle, this is the opposite and this is the adjacent. So the best fit ratio here is going to be tan of P is opposite, which is 8, over adjacent, which is 12, and P is going to be equals to tan of inverse 8 over 12. So I'll use the same. So P is going to be 33.7 degrees. Now a ladder is placed on the ground. So this is the ladder here, and it is placed on the ground at Q to reach the light L. The ladder makes an angle of 70 degrees. Calculate QL. So which means technically QL is going to be the length of the ladder. So what you do is you have opposite with respect to the angle, and you have hypotenuse already. So we apply sine of 70 is opposite, which is 8 over h. H is going to be 8 over sine of 70. Now so h is going to be 8.5. Now let's see this one. A vertical pole RS. So this is the vertical pole of length 1.6 meters is placed touching the horizontal ground. The light produces a shadow ds of the pole on the ground. LRT is a straight line, and the TB is going to be 6.5. Calculate TS of which what you are to find is TS. But if you look at this triangle, let me highlight that. If you look at this triangle here, so this triangle. You have to find out TS, which is unknown. You have 1.6 and you don't have any other help. So right now solving this triangle and finding the unknown is not possible. What you could do is you take help from the bigger triangle. And I can see that in that big triangle, from triangle TLB, I can see that there is this angle T. According to angle T, I have opposite and the adjacent given. I'll use tan of T is opposite, which is 8 over 6.5, and T is going to be tan inverse of 8 over 6.5, which gives you 50.9. So T angle T is 50.9. Now, in the triangle TRS, if you, for better understanding, if you try to construct it here, so TSR, we need to find out this length TS. We have 1.6 and this angle is common between both the triangles. So we already have found out 50.9. So now using this ratio and according to the angle, this is the opposite and we have to find the adjacent. So we use tan of the angle, which is 50.9, is opposite, which is 1.6 over 50.9. And my apologies, this is, we need to find out TS. So TS is going to be 1.6 over tan 50.9. So 1.6 over tan 50.9 is going to be 1.3. So TS is 1.3. Let's take a look at another question here. In these type of questions, the first step is to make a rough diagram, your understanding. From the top of a cliff 88 meters high, let's say this is the cliff here, 88 meters high, and this is, let's call it height as C. The angles of depression of two boats due west. Since it is due west, let's try to take this diagram here. Of it are 18 and 23. So the angle of depression, there are two boats which are at a distance from each other. So let's call this boat 1 and this boat 2. Now, if the person who's standing at the top of the cliff, then we can say that this here is the line of sight. And the angle of depression for the first one is this. So as you can see that this is 23 and this is 18. So obviously this is going to be 18 because this is lesser than the other one, this one, the blue one. And this is going to be 23. The blue one is going to be 23. This is just common sense here. So now calculate the distance between the two boards. So technically you have to just find out this thing. Now if I construct two triangles separately and try to visualize that, this is 88 for boat 2 and this here is the line of sight, and this angle was 23. And as you can see that This is a z, so which means an alternate angle, they are equal. This is also 23. And I can find the distance from the cliff to the boat. This is a. So for this one, if I write tan of opposite 23 is opposite, which is 88 over a, and a is equals to 88 over tan of 23. This is going to be 207.3. So the distance from the cliff to the boat is 207.3. This one here is 207.3. Now let's take another big triangle. And if you look at this one, then this is boat 1, this is cliff, this is cliff top. So this is 88 and the line of sight here, and the angle is 18. So hence the same way it is as well 18. So according to this angle, this is opposite and adjacent. So if we could find out again, tan of 18 is opposite, which is 88 over adjacent, or a is equals to 88 over tan of 18. This gives you 270.8. So this big length is 270.8. All you have to find out is this much. So in order to find the distance between both the boards, you have the bigger length as 270.8 and you subtract 207.3 from it, which gives you 63.5. So this is all about angle of elevation or depression. They just apply with right angle triangles. This is all you need to know. We'll talk about this some other topic in the next session. Until then, take care. Bye.